Welcome to Lesson 3. Today we're going to work on calculating the median. We're also going to work on Lesson 4, which is calculating the mode. So the middle number of the data is known as the median. So let's write that in. We find the median, the middle number, after the data has been put in order from least to greatest. If there are two numbers in the middle, we'll find the mean, which is the average, of the two middle numbers in a set of data. So we're going to start with odd numbers, first an odd number of data items, which is a little bit easier. So it says use a set of data from example A to find the median of the quiz scores. Be sure to show your work. Now the most common error is for students or people in general to just go directly to the middle number. For instance, thinking that this number in the middle of all the data is the median. So that is incorrect. We have to put the numbers in order from least to greatest first. So sometimes I choose to just circle numbers. Start with the smallest numbers. I see that there are 2 3s, and then there's no 4s. I see 1, 2, 3 5s. I see 2 6s and 2 7s. So all of the data has been put in order. I choose not to cross it off, that way I can still see it if I've made an error. So now this part I will cross off. Another teacher referred to it as closing the curtain, so I'm going to take one from the left and one from the right, one from the left, one from the right, and I'm going to continue to do this until I reach a middle number, or perhaps two middle numbers, as we'll see in a few minutes. So the median is actually 5, not 6. So we have to put the data in order from least to greatest first. So let's turn our attention to the next two sets of data. Would you please put these numbers in order first and then find the median? Data set A and B both have odd number of data items. So here are the medians for these sets of data. Let's move on now. Sometimes we are given an even number of data items. So let's explore how to find the median in this situation. So 1, 2, 3, 4, 5, 6, an even number of data items. So we're going to start it exactly the same way. We're going to start looking for our smallest data item. And it looks like it's 66%, followed by 75%, followed by 78%, 80%, 92%, and 98%. So 6 data items. When we go to cross off one on the left, one on the right, one on the left, one on the right, we suddenly see there's 2 numbers in the middle. So we can use our logic and tell ourselves, well, the median has to be exactly in the middle of 78 and 80. So sometimes the median is not necessarily a data item itself. And because these are 2 consecutive even numbers, it's pretty easy to figure out what number is exactly in the middle. So the number that's exactly in the middle of these 2 numbers is 79%, and that happens to be the median. However, sometimes we do not get numbers that it's easy to find the median just by looking at them. So in that case, we have to find the the mean, our average of those 2 numbers. This should be a 78. So we add these 2 numbers and get 158. And then to find the average, we're going to divide by 2 because that's how many numbers we added together. So the sum is 158. 2 will not go into 1. It will go into 15 7 times. 7 times 2 is 14. And then we're going to drop down the 8 and the 1, and 2 will go into 18 9 times. So we came up with the same answer. The median is 79%. So let's look at the next set of data. Again, you don't want to just go directly to the middle two numbers. That's incorrect. We have to put them in order first. And the smallest number is 8, followed by 10, followed by 15, 19, 22, and 24. So we're going to eliminate one on the left, one on the right, one on the left, one on the right. Can you take a guess what you think the middle or the median number is? Again, for this one, we probably could have used our logic, but again, to show you how to do it, if our numbers are a little bit more difficult, we add the two numbers together. In this case, we're going to get 34. We then take that and divide it by 2 because we added two numbers together, and the answer is 17. Would you please try letter D on your own? When you're finished, check back and make sure to describe in words how you find the median. And the answer is 227. So once again, I want to caution you when you're working with data, always make sure you count and make sure you've accounted for all the data items. This happened to be 8 numbers, but as the data sets get larger, sometimes it's easy to lose a piece of data or forget one. Now let's move on to mode, the next page, lesson 4. Lesson 4 is calculating the mode. The number or numbers that appear the most in a set of data are called the mode. And for me, I think it's easy to remember this particular word because most and mode kind of sound similar. So that helps me remember it. We find the mode by looking for the number that we see most frequently. If 2 or more numbers appear with the same frequency, all of them are modes. Sometimes a set of data has no mode. So we can have no mode, one mode, and several modes. It's helpful to put the data in order from least to greatest first, particularly if the data set is large. So once again, we're going to use our data from example A to find the mode of the quiz scores. And it says be sure to show your work. So when we put the numbers in order, it makes it a little bit more clear. So we have 2 3s, we have 1, 2, 3 5s. We have 2 6s, and we have 2 7s. So I often go back and double check. I should have 9 pieces of data. 1, 2, 3, 4, 5, 6, 7, 8, 9. So I've accounted for all of the data items. So now I notice that I have 2 3s, 3 5s, 2 6s, and 2 7s. And even though I have 2 of 3s, 6, and 7s, 5 kind of trumps them all because there's 3 5s. So in this case, the mode would be the number 5, even though the other numbers are repeated. So it says, using the data set below, show your work and calculate the mode. Remember, some sets of data have no mode, one mode, like we had here, are more than one mode. So if we look at this next example and put them in order, we have 5 and 7 tenths, followed by 6 and 3 tenths, 7 and 8 tenths, 8 and 9 and 2 tenths. And you can see that no number is repeated. Therefore, there's no mode. So we have to be cautious. We don't want to put 0 because 0 is actually a digit. So we want to write that there's no mode. We don't want to use 0. So let's look at our final set of data for letter B that we're going to do together. Would you please put these numbers in order? Now as we scan the data, I only see one of these two numbers, but I see two $224, and I see two $230, and there's just one of these. So we're noticing, or hopefully you notice, there's 2 here and 2 here, and they're both represented equally. So we want to write the mode. There are 2 modes. So 224 is a mode, and $230 is also a mode. So would you do letters C and D, describe in words how you find the mode, and then look back briefly because there's one more description of something that's important. So if we look at the data for C, there were two 80%, and everything else was only represented once. And for letter D, even though 7 and 22 were repeated twice, 19 was repeated 3 times, so that is the mode. So one other item we want to discuss is it says, finally, some data items contain what's called an outlier. So let's write that, outlier. An outlier is a number or data item that is very different from the rest of the data items. In certain situations, we choose not to include the outlier in our calculations because an outlier can skew the results when trying to find the center of the data. So if we look at letter D, we could make an argument that 7 is an outlier. If we look at all of these numbers here from 15 to 22, there's a range of 7 numbers, and all of them are in the teens or 20s. However, this is a single digit number. Now, 7 is really not that far from 15, but we could make an argument, and this one we'd probably keep that and not classify that as an outlier. Let's now look at the top set of data. Letter B. As we look, all of the numbers are in the high 100s and mid to lower 200s, except for one number, which is 500. And this one is almost twice as much as the next lowest number. So in this example, 500 would definitely be an outlier. All the rest numbers are more tightly arranged and close together. This one is clearly twice as much as any of the numbers. So 500 would be considered an outlier. Thanks for watching and have a great day.